So the question we're going to answer is function or not a function.
Are you not checking on the board?
Today's short. We may not have time. Okay. Shh. Function or not a function. So the first thing I need is for some kind soul to look back in their notes and let's give the definition of function one more time. Okay, Sean, I saw your hand first. What you got?
A function is a relation where each domain value x coordinate has exactly one range value y coordinate.
Okay, so a relation where each domain value, which is the x coordinate, read the rest of it again for me.
Has exactly one range value y coordinate.
Okay, so I can have a domain value, but it's only allowed to have one range value. So what I'm going to do is give you a relation, and I need you to help me figure out if it is a function or not a function, okay? And so I'm going to teach you some things to look for, or just remind you things to look for to help this. Now, here's the issue that I saw happen in period 2. This is basically the definition from the book. It's the definition that I understand. If you don't understand it written that way, you need to come up with a definition in your words that makes sense to you. That's called learning, okay? So remember, math class is a foreign language class, and just like you do in your core class, and you've got vocab you have to learn, you have vocab to learn in this class, making flashcards, whatever. But if the words on that flashcard don't make sense, then you can, just give me back that definition, but you don't understand what it means. So you need to be able to break it into words that make sense. I added the words in parentheses of x coordinate and y coordinate so that you would have a connection between domain is x and range is y. But again, you need to go further than this. Sam, that's a toy that you're playing with, and it's actually a tool that we use in math class. So put it where it belongs. Do you still have it in your pocket? Where'd you put it? My compass. Did you put it back in the box? You were just playing with it. Okay. Alrighty, so let's talk about this relation. So I've got 1, 2, negative 3, 5, 2, 7, 1, negative 1. And our job is to determine, yes, it's a function, it meets the criteria, or no, it's not a function, it doesn't meet the criteria. Question is, which way do we go, yes or no? Okay, Paul.
It is a function because there's 2 ones in the x coordinate place.
Okay, so you're saying it is a function because there's 2 x's?
Oh, it's not.
Okay. So now it's not a function. So go back and give me your reasoning why. Okay, so make a commitment, yes or no. Does it meet the definition or not meet the definition? Okay, so if it doesn't meet the definition, then it's not. It's negating it being a function. So you're saying it's not a function. So explain to me in detail why you say it doesn't meet the definition and therefore it can't be a function.
Because there's a 1 in the first place and a 1 in the last coordinate.
So 1 shows up in the domain twice, but what's the crucial part to the definition that says it's not a function? What are you saying, Talia? The range value for the first one was a 2. The range value for the second time 1 showed up was a negative 1. Does that meet the definition that there's exactly 1 range value for that domain value?
Yeah.
Those are the same? Okay. Yes or no?
No.
Okay. So it's funny because you guys have flip-flop on me through this whole thing. Yes, no, yes, no, yes, no. So what does that say? You don't understand that definition. Okay? It again says your x value can only have one y value. X showed up 2 times, and there were 2 different y's. So these are different ranges. According to this definition, it says I only get exactly 1 range value for my x value. Okay? So this one is not a function. All right, so what I want to share with you is something called mapping, because I think this is going to create a problem for you guys if you're not understanding the definition. So here's what mapping does. Mapping creates 2 circles. The left circle is called your domain. So I'm going to box this. Your right circle is called range. And all you do is list the domain in the left bubble one at a time, and then you list the range in the right bubble one at a time. So with that same relation that we have, what are the domain values? Cameron K.
1, -3, 2, that's it.
Okay. Why didn't you tell me 1 again?
Oh, at the end?
Mm-hmm.
Because it's not a function.
That's not the reason why we went to do that, Marcy.
Because there's already 1.
Yeah, we don't repeat ourselves. Okay? So I didn't say you were wrong. I just want to know if you knew why we didn't do that. Okay. So now I need range values.
Can I do that one?
So what are the range values? Julia E.
5, 7, 1, -1.
-1. So here's what mapping tells you to do. It says draw an arrow from each domain value to its range. So I'm going to write that here. Draw an arrow from each domain to its range value. Okay? Let's do a nice big purple. So, first order pair. 1 pairs up with what?
2.
So I draw an arrow from 1 to 2. Second order pair. -3 pairs to 5. So I draw a nice arrow. Third order pair. 2 goes to 7. Straight across, right? All right. And then the last order pair says 1 goes to... What do you notice? Now, we already have determined that this is not a function. What does the mapping reveal that tells you it's not a function? What do you see in the mapping that says, up, can't be a function? Juliana?
Well, sort of going out on a limb here.
Go for it.
So the 1 in the domain matches the -1 in the range.
Okay, is that the only reason why? Think physically, what do you see in the mapping that confirms this is not a function? This is not a function. Okay? Breck, we'll try you. That's not a reason. I can understand you thinking that. It's not because one line crosses all the other lines. That's not the reason. Okay, Sam?
Because there's 2 lines going from 1 number.
That's the reason. Remember the definition said that a relation has 1 domain value with exactly 1 range. So I should see 1 arrow coming out of each domain going to some range value. That's it. This one, I've got 2 arrows coming out of 1 domain number. So 2 arrows from 1 domain, not a function. So that's one of the most clear pictures that I can give you. Now, sometimes the worksheet you're going to get uses this notion of a map, and sometimes it doesn't. So I'm going to encourage you guys to use a map. Now, what I really need you guys to understand is what happens when you graph. Okay, so we're going to do a graph real quickly of the same 4 ordered pairs. And I want you to see in that graph, we already know it's not a function, so what could we conclude why it's not a function?
Because there's
Oh, well, wait, girlfriend, we're not there yet. Let me graph. You're so excited. Woo! Okay, so we have 1, -3, 2, and then, ooh, all positives. Okay. One, two, three. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. That's my y's, that's my x. All right, so here's what I need you guys to do. Help me out. What's the first order pair? What was the first order? 1, 2. So 1, 2. Okay, second order pair. -3, 5. Okay, third order pair. What was it? What was the third order pair? 2, 7. Okay, and the last order pair? Okay. Now remember, we already know this is not a function. Do you see something interesting in this graph that reveals it's not a function? Okay? Kyler?
There's 2 numbers on the same
No. What kind of line? What kind of line is this one?
Y.
No! What kind of line is this one? It's not called a Y line.
Horizontal.
No! Yes, the sun rises this way. No! What's this called? What kind of line? Vertical line. Okay? When I graph ordered pairs, if 2 of the ordered pairs are on a vertical line, that means it's not a function. Remember, 1x, 1y. If I have 1x and 2 y's, then they're going to be on the same vertical line. So, 2 points on same vertical line. Not a function. So there's 3 ways that you can determine if you have a function. Sam. Horizontal line means you have different x's and the same y. Not a problem. The direction or the definition says 1x pairs up with exactly 1y. It doesn't mention anything about y's and how many x's. That doesn't matter. 1x has only 1 y value. Okay, Sean.
Do we have to graph this?
Well, you need to determine whether it's a function or not. If you can't do it by looking at the ordered pairs, then you do a map. If you can't do it by mapping, then you do a graph. So you've got 3 options how to figure out the answer to yes, it is a function, no, it's not.